testing is one of the most widely accepted forms of performance measurement in the auto industry. And while dynos are incredibly precise machines, the accuracy of the test depends on an operator's ability to control a variety of variables. Now today I've got the C7 and I want to know what this thing can really do. So to ensure I get the most accurate test possible, I'm meeting up with my friend Bert Heck from K&N Engineering.
Hey, good seeing you.
Good to see you.
How you doing?
Good, how about yourself?
Good, good.
Did I not tell you I would bring a car worth putting on your dyno?
Yes, you did. Beautiful car.
Yeah.
Why don't we do this? Why don't we bring it in the shop? Let's look at our different dynos we have,
okay,
and let's get this strapped in and see what it'll do.
All right. Cool. So I know different dynos do different things. Tell me about the setup that you have here at your facility.
What we have here, this is a Dynojet all-wheel drive inertia style dyno. What we have over here is a Superflow inertia eddy current link style dyno, and then over here we have a Power Sports inertia style dyno.
Okay, now is this one load bearing?
Yeah, this is a load bearing dyno.
Okay.
So what this dyno is, it can simulate like a percent, like if you're going up a hill, if you want to put a 10%, 20% load on the vehicle, this dyno will do that.
Okay, all right, well let's get the baby on here.
Let's bring it on.
So these are the drums, they're huge.
Yeah, as you can see, the drums, they're 48 inches in diameter, and they roughly weigh about 2,500 pounds with the both of them. The weight is what helps keep the inertia stable when they're making the horsepower runs.
Dude, you have to get down here, man. It goes all the way to the front, like all the way back there. Dude, that is insane. I never would have guessed it'd be so massive.
Yeah.
So how does this setup differ then from a four-wheel drive dyno?
Well, what'll happen is, as you can tell, this is a two-wheel drive dyno. So the pit is the size you see it here.
Right.
But now in the four-wheel drive dyno, the pit goes all the way past the front axle. So now there's another set of drums forward of the vehicle.
Okay.
And what makes it really cool, because of the different wheelbase of different vehicles, the front drum is actually on a set of tracks, and we're able to move it front and back to get the wheels where we want it positioned on the drum. So there's a lot more going on the four-wheel drive dynos.
Okay. All right, Bert, walk me through this process. What are they doing here?
Okay, they got the car on the dyno now. So now the next step what we'll do is we'll strap it down. So what we'll do is we'll go underneath the car and find some good chassis spots that we can tie the car down.
And then once it's strapped down?
And then what we'll do is we'll start the car up, we'll center the car on the drums. Once the car finds its happy spot, we'll go back, we'll make sure everything's tight, we'll hook up the sensors into OBD2 so we can read the tach and all the information that the computer will read off the car, and then we'll be ready to make a pull.
Okay. Okay, so we just did 2 pulls.
Yep.
For people who don't know what that means, can you explain that quick?
Yeah, what we did is we get the car, we start off in first gear, second gear, third gear, and this pull was a 4th gear pull. So once we got the car in 4th gear, we brought the car up to about 2,500 RPM, and then what we do is get there, get the car settled, and then go full throttle. Then we take it all the way up to max RPM, which was 6,500 on this pull here. And on the dyno chart, as you see, it made 402 horsepower. So once it made that pull, we'll let it cool down between 2 to 5 minutes, depending on how fast the car can cool down. Then what we do is we'll reproduce the same thing as what we did on the first pull. So that way everything is consistent.
And our numbers are really similar between the 2 pulls.
As you can tell, the second pull was 403. So this car is very, very consistent, which is really, really cool. And you can tell that the torque is really flat. So that's also what performance guys want, you know, a nice flat torque curve. So very impressive.
Yeah. So can we do a top speed run?
Yeah, we can let it fly and let's see how fast we can get this thing.
Yes.
Jump on in.
Right. Hit it, Pops. about our top speed run.
Okay, well, if you look at the graph, at the very top one it said 281 horsepower, and that was at 4,000 RPM. Now, if you look at the second graph, it went 191 mile an hour at the 4,000 mark also. So what has happened is GM has put a speed limiter in it. Whether it was set at 190 or 200, you know, they may give a factor there of maybe 10 mile an hour.
Okay.
So basically, GM will only let this car go to 200 mile an hour as it sits right now.
Okay.
You can get in and mess with the computer and do all that kind of stuff and get higher mile an hour and whatnot, but off the showroom floor, this car is a 190 mile an hour car.
Not bad.
Now you got to remember, there's no wind drag or any of that. This is just all a stagnant test. So if this was real world, would it make 190 mile an hour? Well, you know, that's where you have to do the real world test.
Dismantling my car. So you built a custom filter for the C7?
This is a prototype filter for this car. And since this is really kind of the first car that we've seen, this is a good opportunity for us to throw it in to see if it fits.
Right. So if you could get an extra 10 horsepower out of this, would that be an exciting number?
10 horsepower would be a really good number, and we'd be happy with something like that.
Okay. Okay, so the blue line there is our baseline run. Mm-hmm. So we've achieved over 15 horsepower,
yeah,
right?
Just by showing on the runs that we have there, we're seeing 15 up to 20 horsepower gains. It's not bad for a prototype filter. It's a good baseline for us. We're pretty happy. It's leading us in the right direction.
Well done.
Yes.
All right, so I know we needed to get this on the dyno first thing this morning because with each passing minute, this room gets hotter and hotter.
Right.
But now that we're done, can I take a look at your facilities?
Yeah, we can go out back and I'll show you the facility and show you where all the magic's done.
All right.
All right.
So what do we, these are molds here?
Yeah, so what happens is after we get an air box, for whatever the application is, let's say Corvette, we have our engineers design the filter and design the mold. And then what happens, once all that's designed, it'll come down into the machine shop. K&N does all of its own tooling. We build our own machines to make the filters. So everything is built in-house.
So this is cutting tools.
And then that right now, the machine's in right now if you want to take a look.
And what's all the liquid? Is this lubrication?
It's a coolant,
Okay.
Coolant and lubrication.
Wow. And then if you need more, you can just manufacture more.
If we need more, we can manufacture more. And that's the beauty about doing it in-house. We got the drawings, everything's designed. Just come down here, throw some metal in there, turn the machine on, knock out some parts.
And here are the filters.
Okay, this machine right here is building our clamp-on filters. We can build different part numbers all at the same time. So as you can see, the different height, the different medias. So the one thing about K&N is this machine here, we built it. We designed it, we engineered it, we built it here.
Wow.
So if we want to make 100 of the same part number, we can do it. But if we want to build one of one, we can make the change here. So it gives us the advantage of the change on the fly,
Yeah.
which is very huge in this market.
Absolutely. I didn't even know. I thought you always had to do a batch with most of the machinery.
The good thing about this is we don't have to do that. Let's say we're building a one-off filter for a customer and he needs 20 of them, like tomorrow. We have the ability to just make him 20 filters, get them box wrapped, and send out that day. This department here is our kitting department. What these people do here is when K&N develops an intake kit and we get all the finished goods and whatnot, this is where it all comes together. As you can see, there's a lot going on because there's a lot of pieces that are included in our kits. And we box roughly about 2 to 2,500 boxes in an 8-hour shift. So they're staying pretty busy.
Yeah.
We ship roughly about $500,000 a day. So this is a very, very busy part of K&N. But when you get in here in the mornings and midday when the orders come in, that's when this place is really off the hook. Especially like on a Monday morning, you don't even come down here because it's just like forklifts running around, boxes flying. So, but this is really where it all stops. It comes here, goes in the trucks, the containers, and is shipped around the world.
Bert, thank you so much for showing us what the C7 can do. It was really fascinating to see the way the prototype filter impacted the power output.
I just want to say thank you for bringing it in. I mean, we here at K&N, we love it when you magazine guys come in with the cool toys, and it was a good day for us.
Good, good.
Yeah.
And after seeing your facility and all the parts you make there, I think I need to bring my WRX down here, get a little K&N magic going on there.
We got magic for it.
Yeah,
so.
deal?
Nah, deal.
Deal, all right.
So he's pulling the factory filter out of the airbox now. And then, so as you can see,
So much thinner.
yeah, and it's paper, and then you'll fill it. I mean, you could,
Oh yeah, wow.
so that's good.
Juicy.
Yeah, I mean, it's made to last 5,000 miles, 10,000, whatever the manufacturer recommends. Now, if you grab our filter, you
Whoa.
can feel there's a difference
Like
there.
covered in barbed wire out here.
Yep.
That's pretty awesome. Wow,
So-
it's really different.
Yeah, and one of the things that we do is it's a direct replacement. So when we have filters like this, there's no drilling, screwing bolts in, there's nothing. It's basically pull the factory one out, take the cane in, slide it in.